Car design is more than just sketching a pretty shape. Today's car has more than 7,500 individual parts, all of which have to be designed, developed, tested and manufactured. It can take a 5-year investment of skill, effort and money before this piece of modern technology takes to the road. Our knowledge of car design has increased a great deal since this little baby first appeared on the road, but something has remained the same. Apart from satisfying the likes and dislikes of future owners, the car has to be designed to suit the period and environment in which it will operate. So, from the Ford Model T of yesterday to today's family saloon, manufacturers try to design a car to suit the times, and that takes years of planning and preparation. Combining knowledge gained from previous models with the results of up-to-date market research and detailed studies of competitors' cars, the product planners prepare a features list, the first stage to a complete written description of the new car. All car design is a compromise. The need to satisfy within a given body size the public's demands on economy and performance, reliability, comfort and interior space. These can all vary dependent on the size of the car. The aim must be to create a balanced package, the right relationship between the exterior skin and the interior space available for mechanical parts, passengers and luggage. At this stage, the artists will have no preconceived ideas about the shape of the car. They will have been given the general direction, but their sketches and coloured drawings will be exploratory. The next stage will be to decide what engines and gearboxes will be used. All the alternatives will be considered. The discipline is exacting. Despite the unpredictability of the marketplace, the new car is expected to appeal to the widest possible audience. It must also conform to all present and anticipated safety legislation. And it must be produced efficiently and reliably, not as a one-off, but in thousands every day. Full-size profile drawings are made using adhesive tape on sheets of acetate to allow subtle and immediate changes during design review meetings. At the same time, others in the design department will be concentrating on suggestions for the interior. Each new idea will be assessed on the grounds of function, cost, and appeal. A citizens' band radio or passenger TV can be suggested, but neither will be included, this time at least. It is the more fundamental parts that get the most attention. About 3.5 years before the car is announced, a preferred model will be recommended for further development. By now, there are full-size models in clay to allow the designers and senior management to make sure the overall proportions are correct. Using a variety of tools, the craftsmen create the required shape by sculpting, actually scraping away the clay. They work closely with the design team, translating their ideas into full-size, three-dimensional form for the first time. The results are so lifelike that any outsider could be forgiven for trying to get into them. This vehicle may look solid enough, but only the wheels and tyres are real. Whether a rear light or a steering wheel, each clay model is built up on a wood or metal framework.
'67 coming in.
Working together, the designers and engineers have progressed from the huge amounts of paperwork and ideas to a life-size form. The character of the new car, outside and in, is now beginning to take shape. Smoothed over the clay by hand or roller, a thin piece of plastic on which paint is sprayed helps complete the picture. It can be replaced with a different color if necessary. The clay body shells and interiors are subject to review and modification throughout the car's development period. Color and texture add to the illusion that this is the real thing, as the proposed instrument panels and interior layouts are displayed for assessment on wooden jigs known as bucks. This is not just a question of appearance. Seating, instrument layout and driving position can all affect the driver's own performance, and ergonomics are taken into account before the product planners make their final decision. So the work of the artist is gradually giving way to the hard discipline of engineering, and the clay models have to be completed with total accuracy. A device called a scan mill is used to measure and record the surface shape of each part in 3 dimensions. The scan mill's touch-sensitive probe travels across the surface of the clay, and at each point of contact, the machine automatically records its position. Stored on magnetic tape, this data is fed into the computer network and is available to anyone with a graphic display terminal. This drafting machine will translate the data into drawings the size of the actual car to enable others to see the implications. And through worldwide computer links, engineers in other countries can exchange data with their overseas counterparts. The computer explosion is opening up vast new opportunities for design engineers. Never bored with repetitive tasks, the computer can store a great deal of information and allow the designers and engineers to adapt a design to meet a multiplicity of needs. Using the Longitube system, the designers can make instant changes to a graphic display. On command, the computer will turn a plan drawing of a component into a 3-dimensional shape. If a design change is needed, an alternative can be considered quickly. While all the development is going on, new ideas and changes in design are being tried out on selected members of the public at customer clinics. These are held in various parts of the world, and the results are carefully monitored. Today, a crucial stage of car design and development takes place in a wind tunnel. To many people, aerodynamics may be a mystery, but its results can drastically affect a car's performance and economy. It is now possible to design a car shape that uses less fuel by causing less air resistance as it moves. By passing air over the car body, the designer can see whether the proposed shape has what is called a low drag outline or whether it generates turbulence. It can take thousands of hours of wind tunnel testing involving minor modifications to achieve results as successful as these. But the time will come when all the data will be translated into metal for the first time. The car's announcement will be about 2 years away, and program approval will by now have been given. These molds will cast the dies for the first prototype examples of the new model. They're only hard enough to form about 70 panels. The early pressings are all hand-finished. Some parts are actually handmade. And at this stage, the building program is still flexible enough for minor alterations to be tried. The first floor pan is carefully maneuvered over a specially prepared jig. As the wheel arch slips over the shock absorber mounting point, the first metal prototype begins to take shape. After welding, the body shell is measured at key points. Every weld, every curve will be checked. No distortion can be tolerated. The vehicle must conform to all the data on paper. And that includes the requirements of safety legislation and the results of the continuing program of safety testing. For example, the effects on the car's occupants of a frontal impact, here simulated on a high-speed sled. So, for every hour spent on design, 100 are spent on testing, analyzing, perfecting. To check performance and quality, laboratories become make-believe worlds for the endless testing of component parts. Elsewhere in the world, another element of research is going on. A mystery vehicle is about to take to the road. Hidden under the skin of established production models, new mechanical components, engines, gearboxes and suspension parts will be tried out during thousands of hours of arduous road testing. Meanwhile, other components are receiving their initial punishment on specially constructed test tracks. In cars often linked by umbilical cable to a mobile laboratory carrying sophisticated electronic equipment which monitors performance.
Right, slowing down a bit now. Slowing down and pulling into the right-hand side.
Hour after hour, this testing continues, over every surface imaginable, stressing components to the limit and beyond. At Ford's Proving Ground in Belgium, a car under test can drive down a country lane, over uneven cobbled tracks, or on a major highway, and all within a 6-kilometre route. As part of the 50 kilometres of roads and tracks here, engineers have reproduced exactly some of the worst road surfaces of Europe. This testing goes on 24 hours a day, week in, week out, proving the work of the designers and engineers under all conditions and all climates. The dust and heat of the Arizona desert, 100 degrees in the shade, can take the cooling system beyond the limits of probable use. While in Finland, this car's engine must fire in 6 seconds on choke despite being left out all night in the bitter 27 degrees below freezing of the Arctic Circle.
That's it. It runs good.
Yeah. Yep.
Every component on the new car will be put through an equally punishing program before being approved. Finally, the heads of the many departments involved in the car's creation will test it alongside its major competitors.
We're driving for 20 minutes. I'm going to drive.
This management appraisal is the final seal of approval, and a new car is committed to production. The tooling and dies prepared, Start Training Build, or STB, begins. The workforce becomes accustomed to the techniques of assembling the new car, and so do the robots. One month later, the first of the thousands that will be completed daily runs off the end of the assembly line. A new car is born. In all, it could have taken about 5 years to reach this point. But already the product planners, the designers, the research engineers are hard at work developing new designs, new materials, and new components for its replacement years hence.